Howdy everyone, you're listening to the Blue Jeans and Boots podcast, where genetics grad students talk about how to navigate a PhD program while trying to stay sane. We also invite faculty from our interdisciplinary program here at Texas A&M onto the show to pick their brains about their research, what it's like being a principal investigator, and their journey to becoming a professor here at A&M. In this episode, we'll continue talking to the speakers from this year's Genome Editing Symposium here at Texas A&M. They work in various sectors from academia to industry to government, yet they all use knowledge of genetics on a day-to-day basis. Today, we hope to get more insight on how our listeners can apply their degree post-graduation. My name is Anthony, and I'll be one of your hosts today.
And my name is Joe. I'll be your other host today. Thank you both for agreeing to be on the podcast.
Thanks for having us.
Absolutely. And I'd like to start off, if you both can briefly introduce yourselves and talk a little bit about your research or what you do day to day.
I'll go first. Thank you. My name's Matthew Burg. Go by Matt. But on a day-to-day, I work in industry, in gene therapy industry. My job currently is a director position in manufacturing science and technology. And what I do in that position is work with companies to help get our drug product made so that we're able to go to clinical trials and hopefully eventually commercialize said drug product. So that's what I do on the regular.
Awesome.
Cool.
Hello, my name is Washington da Silva. I work at the Connecticut Agriculture Experiment Station, associate scientist. I work directly with growers, with lawmakers from the state, at the state level capacity. I also mentor students, and I have my own research program in the station. It's located in New Haven.
Very cool. A lot going on.
Yeah, so you guys both decided to leave academia once you got your PhDs, correct? What made you make that decision? What was the biggest factor for you?
So after I got my PhD, I did do a short postdoc. And in that postdoc, I ended up working with a god in the AAV world, Mavis McKenna, Dr. Mavis McKenna, who's passed, unfortunately, but her legacy will live on in the AAV field. And that basically was a door to me being able to find a job outside of academia. And one of the big drivers was financial. At that point in time, I had 2 kids. I had both my kids while I was in grad school, and making, a postdoc salary, and having a wife who's a teacher in Florida, if you want to be able to provide so that your kids can have the things you did at growing up, this is kind of what drove me out into the industry to some degree. Plus, I'd never want to write a grant.
That's fair.
I do not want to, that whole rigmarole and writing and going through that and begging for money idea is not something I've ever desired.
Right.
Yeah.
Well, in my case, my PhD advisor was a USDA fellow. He works at USDA. So I already had an idea how it was to work for the government. So there was this opening for the state level, so I applied for, and they offered the position. Then I ended up going there. I was always thinking maybe switching to academia level, to a big university. But after time, I started lecturing, giving some classes just for fun, because I like teaching. But then I like the idea behind my job, which is a lot of flexibility to pursue the dreams and ideas that you have. And I thought that was better for me over time. And right now, I don't think I want any other job, because it's just the flexibility. And also I teach because I like. I don't have to teach. I have 100% research appointment. So yeah, I just feel like there is a lot of flexibility. There are some red tapes too, but it's just we are able to pursue the ideas you have. Sometimes in academia, you need to focus on some levels of research. You don't have that flexibility.
Mm-hmm.
I'd also like to add that part of going into industry was so that the science I was doing was very applicable, right? Like, we're making drug products that could keep children out of wheelchairs and have much better lives. And, I saw a lot of times too in academia that, as Washington was pointing out, you're spinning your wheels, or you're in a very focused lab that's some of the science might be applicable in the long run, but it's not making its way outside the doors.
Mm-hmm. Yeah, it's definitely hard to combine that clinical aspect when you're in a research lab. I know a couple labs that do it on our campus, because we are fortunate enough to have collaborations with inpatient facilities. But yeah, you're definitely right. When I was working in industry, it definitely felt more translational. You could feel the impact of your work more, I think.
So we talked a little bit about what y'all do right now. Could you speak a little bit on what got you to your current position? What like your professional journey, your academic journey has been in terms of where you went for your bachelor's or for your PhD, and the experiences that kind of shaped you into your current role?
So my journey is a little different than most. I, went to undergrad right after high school. Probably shouldn't have. Didn't do very well academically. It took me a long time to get through. After that, I, went out and started working as an environmental scientist. That wasn't the job for me. I then switched and became a teacher in Florida. And while I was doing that, I then got the opportunity to be able to go back to school. And like I had said, same idea of going into industry. I went back to school to try to, get a better job, looking to go into pharmacy or medical work, right? And started taking chemistry and found out I was really good at chemistry. And so I quit my job and did the entire chemistry program in like a year, and then got into grad school. And, during that journey of going through all of the chemistry programs, I fell in love with biochemistry specifically, and, enjoying all of how you could get proteins to do this and that and the other thing. And I was like, man, I got to keep going here. And so went in and did that for a few years. And Mavis happened, as I mentioned her before, was on my committee, and through like collaboration, she knew me and she offered me the opportunity, and I took it. And I have a very adaptable personality, so when things arise that look like a good opportunity, I tend to follow them.
Well, in my case, I switched fields many times. I was a medical student for a couple of years, and then I quit and went to engineering school and finished up as a mechanical engineer and also in agronomy. And then I was doing my master's studying fungal and bacterial disease. And then I read a book from Edward Wilson. It's called The Letters to a Young Scientist. One of the things he said was that if everybody's going to one direction, go to the other direction. So I was studying fungal and bacterial disease, and I saw a lot of people doing the same thing. And then nobody's actually was studying viruses. That's when I was like, okay, let's try this new thing. So I switched to entirely to study viruses. So I went to Cornell University, and was a great lab where I was able to ask some interesting questions. I had a lot of freedom to do whatever I want, really. And that was very important to me because I always want to be a scientist. And in my mind, to be a scientist, you need to ask a lot of questions. And again, sometimes you're restricted in what you can do. So that was the best move I made, and that's my piece of advice to people too. Try to look into those things where your passion is, and don't try to follow the crowd too much.
Yeah. I think there's a common thread between both of your answers, and it's adaptability, it's being open to new opportunities. And I think that, especially for PhD students, we get really zoned in on our project, whether we're really interested in it or that's just the direction that our lab is going in, and we kind of get tunnel vision and we fall into this rut where it's just like whatever we're working on is the only thing that we're looking at. So I think that that's a really good piece of information that you guys just gave to all of our PhD student listeners and applicants, is be open to the new possibilities. There could be better things in different research areas or totally different opportunities altogether. So,
yeah, no, that's a very good point. And I would add to this is that, when I was doing my PhD, I was so focused on some techniques, high throughput sequencing. I knew how to make libraries, do all the bioinformatics. And then my mentor came to me and said, Washington, listen, you should not fall in love with your techniques and also the area you're in, because science moves along, and tomorrow you're gonna have to learn something new. The techniques get old. Your area of research tomorrow is not gonna be very viable. You're gonna have to switch. Focus on the big questions, research questions, because then it can be translational. You can switch as you go, and then that was the best thing I did again, because, in my job, I was hired to do something. I do something totally different because I'm focused on the big questions rather than details specifically.
Right. Flexibility seems to be really important. And I think that, like Joe was saying, a lot of grad students get into that very rigid idea of, this is how the assay is supposed to work. Why isn't it working? Tear everything apart, trying to figure out what's wrong, but being adaptable and trying to say, okay, what can I do to fix this? Or what can I do instead to get a similar result? And not getting pigeonholed into that spinning your wheel cycle.
Yeah, last year at the Genome Editing Symposium, we had a speaker, Dr. Robert Jinkerson, and he gave a talk. And he started off his talk with a really interesting analogy, and I really hope I don't butcher it here, because he definitely delivered it almost like poetically. But he talked about how there was an evolution of the way that we as a society have consumed ice, and how ice was harvested and delivered to people, how we had people literally carving it out of glaciers or frozen lakes, shaving it down. People who would carry large blocks of ice to households, pretty laborious tasks, and how it's obviously evolved since then. We don't carry large blocks of ice to houses, but people have developed freezers, and now there's refrigerators that have freezers built into them that can create, ice with their own water supply and everything. And he kind of left the audience with saying, do you want to be someone who delivers ice and shaves ice, and that's the one thing that you want to focus on? Or do you want to just have a larger goal of trying to make ice more accessible or supply the most amount of people with ice as possible? And it kind of opens up your realm of thinking. He's getting into something that you touched on before, but don't get so tied to a technique, and think about the big picture and the bigger question at hand. But I hope, Dr. Jinkerson, if you listen to this, I hope I did a good job. So we talked a little bit about advice to graduate students, but on our podcast, we have a lot of students that are interested in applying to graduate school. Is there any piece of advice that you would give incoming graduate students or prospective graduate students that are still filling out applications about how to get the most out of their graduate school experience, or if there's just any advice that you would impart to them?
Yeah, for sure. You are going to spend a lot of time in grad school. So when you pick where you want to go can be part of it. Who you want to work for can be part of it. All of these things have to be taken into consideration when you're thinking about going to grad school. And some people, they end up going to grad school and they don't get into the lab they thought they were going to go into, and that can cause a lot of problems and conflict, and it really, you see a lot of people leave. So, find a school that will have the kind of programs you're okay with, that's diverse, right? And as the incoming person, talk to as many people as you can, open collaboration as early as you can in your research, learn other people's things that you can work with, so that you're not a one-show pony if things aren't working out for what project you're on in the lab you're on. In fact, most of my publications in grad school were from all of my collaborations. I literally don't think I've published anything that's in my dissertation. It's all from being opportunistic and realizing that I had skill sets that I could apply to other groups, so that we could learn more about what they were doing, and really, diversifying some of the stuff they had and helping them get, research done. So they were opening their opportunities for grants and things like that as well. So really not just realizing you might not be studying that one thing you were hoping to study. Be ready to learn everything you possibly can, because that's what's going to make you a great scientist.
Yeah. And I think you hit on something that was, I've seen it happen even just in my 3 years in graduate school so far, but people get really kind of gung-ho or set on being in a specific lab and wanting to be in that lab, instead of thinking about what you want, at least from what I've been told, and this is advice that has worked out for me so far, but think about what you want to get out of your PhD, whether it be the skills, the technical skills, or if it be lessons or the mentorship, and think about it more like in the big picture sense. instead of it being tied to such a specific lab, think about all the labs that you rotate in and what could you pick up from each of those labs and how they align with your goals and what you want to get out of grad school. So definitely.
Yeah, no, I think you guys touched base on some very important points. Collaboration, of course. I would say also, to me, that's what I tell my students, work on yourself. Try to find out who you are, what you like doing, what your passion is. Work on your emotional intelligence, because grad school doesn't have to be, this miserable time of your life. Actually, I had so much fun during my PhD, right? Because I was able to think outside of the box, have the freedom to do so. So yeah, choose a place where that's gonna match to you, not just to your interest. Because at the end of the day, work-life balance is very important. And if you're not doing a good job on yourself, the chances are you're messing up at work too. So work on yourself, trying to especially find your strength. Another thing I tell people is that don't focus too much or solely on what you're doing. That's expected. You need to take certain classes, you need to finish your research, but reach outside, especially professional development classes. I always say this to students because that's how you learn how to communicate, how you use your strength to know yourself, and I think that's very important. I took a class, was professional development, and we spent like 3 months just to learn 3 things: stop and think. And that, if you get into the mindset, that helps you along the way.
Where was that class at?
It's called a professional development class. Usually it's given by at the business school. Because,
Okay.
In science, we don't have that type of preparation, but business school, they do. And it was the best move I ever made because they really taught me how to express myself, how to be efficient in what you do, time management, how to find your strengths, because that's extremely important again, to find who you are. Because if you don't do that, at the end of the day, it doesn't matter where you go, you're going to be miserable because you don't know what's bothering you, what makes you happy. Try to find those things. And that's what I tell all my students.
Mm-hmm. Another thing I was going to say is be prepared to feel dumb. And that's a good thing. Like if you feel dumb in the room, then ask the question. Like you're going to, at some point in time, you're going to be the person in the room where other people are going to be like, I have no idea what this guy's talking about because he knows everything about this, but you're not there right away. And it's going to take time for you to get there. So be okay with feeling that you don't know anything that's going on around you. Like be prepared for that. It's going to happen, but it's not a bad thing. It's a good thing.
I think that's what contributes a lot to the imposter syndrome that grad students feel, is that they think since I'm in grad school, I should know these things. Mm-hmm. But that's the whole reason you're here, is to learn.
Exactly.
You're supposed to be a sponge. And if you don't say, I don't understand, can you explain, or can you elaborate on that, or can you try to, get me to a point where I can understand the concept that you're trying to explain? If you just sit there and nod your head, you're going to stay in that dumb feeling space.
Mm-hmm.
We're in school to learn, so it's totally okay to ask questions. That's stuff I tell my undergraduates all the time. I have to remind myself, so I'll probably be playing back this part of the podcast to myself. But yeah, absolutely. Okay, I have a question about your career path trajectory and journey. Were there any obstacles that y'all, I'm sure there were, but if there's any particular obstacles that y'all have faced going for your bachelor's or your PhD, and then everything after that to your current position, that kind of stick out to you that you think was more of like a defining moment?
Yeah, mine's pretty straightforward. I got thrown out of undergrad for grades. I went back and finished. My GPA was slightly higher than George Bush's when he graduated.
Nice.
So there's always that.
Remember, you're in Texas too, so they love the George
that
Bush.
on purpose. And so, I had to reteach myself stuff to be a good teacher. I learned how to become a good teacher from teaching and listening to the people around me. And then, when I went back to get into graduate school, I did, like I said, like the chemistry program, and I ended with a 3.97 and took all the chemistry classes in like a year.
Wow.
And that was amazing. Like I had realized I had overcome this obstacle where I thought I couldn't learn, and I thought I couldn't be this guy that could do this. And I got into grad school, and, there were times that, my PI said, hey, if you want to go into industry, why don't you just get your master's? Why are you doing this? And I said, because I need to prove this to myself that I can earn my doctorate here and do it. And I pushed myself through, and now I'm Dr. Burg. So like, it's great. Yeah.
It's a great story. What do you think when you went back to school? What do you think kind of switched like in you that made you just go for that 397 and just absorb everything?
I went out and lived real life. Like a lot of students who go to grad school are applying right after they've done undergrad. You know, I did mention I probably shouldn't have went to undergrad right away. I should have been out shoveling rocks until I hated it so much that I went and was focused on doing the right thing. But after having like lived a life and being a teacher, I was making $27,000 a year, right? And they're like, "Oh, we'll give you 24 to come to grad school." And I was like, "Yeah, I'm all in. Let's go," right? And it was like a big change. Like I, you know, it was time to be a grown up. You know, I would wake up at 7 o'clock in the morning, drop the kids off at daycare and whatnot. I'd be on campus, and I would just work like a normal job because I was so used to it. And so, you know, I had this lab to myself every day till like 10 a.m. because nobody would come in because everybody else was a grad student or, you know, everybody else or, you know, and I just, yeah. And I always would, and I was so used to being a professional, like I would approach my professors as if they were coworkers more so than professors. I never looked at them as like, "Oh, it's a god." I would walk in and just be like, "Hey, I got a question. How do I do this?" So just, you know, go ahead and, you know, grab the bull by the horns. Another Texas reference.
I like that.
Well, in my case, I'd say is mentorship, because I didn't have mentorship when I was undergrad. It was the dream of my life to become a medical doctor, and I got to medical school after, you know, suffering. And I got there. My grades were like almost perfect. Still, I didn't have a sense of belonging. You know, the imposter syndrome really hit very hard. But I didn't have a mentor. I didn't have anybody to give mentorship. That's why I focused so much in my work for my students and postdocs, make sure that they are well mentored. Of course, it's limited to my capacity. And that's why I reach out to mentorship classes, courses, because I think that's very important. Sometimes you have the talent, you have the energy, but if you don't have the right guidance, you're not going to go too far. And to me, that was what really redefined my life. That's why I switched so much. And when I was trying to go to grad school, luckily I had options. So instead of looking for a particular program, I was looking for the mentor, somebody who would take me in and teach me, you know, how to get there. And to me, that's very important, mentorship, because again, without a nice mentorship, your life is going to be very, very hard.
Yeah, and on that note, you know, like when I picked the guy I wanted to have as my PI, it wasn't necessarily because of the research he was doing. It was more that I had talked to him so much and taking courses and stuff that I knew I'd be able to get along with him for 5 or 6 years. Like I knew I'd be able to have that kind of relationship with him that I could just walk into his office anytime. And that was, you know, I think very helpful.
I think that's a really big factor in choosing your graduate school PI. And I think that's a hard thing to assess in that small rotation window that we have. So I guess this is just my plug to the listeners to try to get that contact with those mentors that you're interested in talking to early on before coming for your rotations once you actually get into the program.
And if you can't talk to them, talk to the graduate students.
Right.
Talk to especially the ones who've been here for 4 or 5 years or wherever you end up, right? They're going to know more about all the professors than they know everything. So they're a very good resource.
Mm-hmm. So I guess on that note, for the grad students who are getting ready to leave, to go into either industry or into government, do you have any advice for them on how they can prepare themselves for, going back or either going back into industry or going into industry for the first time out of academia?
Yeah, for sure. You're going to be, when you're leaving here, you're going to be probably the most knowledgeable person about one little thing in the world. I can tell you that industry is not going to be super excited about that. What they want to know, and you may have heard this from some of the other guys that were talking earlier today, they want a story. So when you write your CV, you got to write a story. Talk about all the different things you've accomplished, all the different programs you've been involved in, all the different techniques you have. But don't write it like, nobody wants to read part of your dissertation, right? They want to know what your skill sets are. Mentoring people, right? If you get undergrads, it's awesome, especially because as a PhD, you're probably going to end up in a position where you have people working underneath you if you go into industry.
Right.
Right? So being able to prove that you already have those leadership skills, those are huge. So take the opportunities of these things that you sometimes take for granted because, you're a grad student, you're forced to teach, right? If you keep teaching, even though like you can just handle the extra time and take more classes and be like, yeah, I did this just so I had that experience, like something like that, all these little pieces that you have along the way, and make sure you're capturing those in your CV. It's not just your straight research.
Mm-hmm.
Yeah, I totally agree. And that's why I say reach out outside of your field, because unfortunately in science, we are focused too much on doing the research, but you're not working ourselves. That's why, again, go and try to find some professional development classes, because that's going to help you to sell yourself the best way possible, right? It's going to help you to how to behave in a setting, like you are going for a company where you're going to have an interview. It's different than when you go to academia and try to become an assistant professor, or you go to the government. So when you take those classes, they teach you how to navigate those different situations. And to me, that was, again, the best thing I ever did, the best class I ever took, without any doubt. So reach out to those resources. There are many resources out there. Every school has at least some people doing business. That's where they teach you those things. Psychologists are teaching those classes. They are teaching you how your mind works, right? That's extremely important, because it doesn't matter how much you know, especially if you become too focused on one little thing. You go to the industry, like he was saying, they don't care. They want somebody who is able to adapt, because things change all the time. Are you that person? How are you going to sell yourself? I know how to run a PCR. Who cares? I know how to do a bioinformatic pipeline for HTS data. Who cares? There are a lot of people who can do that, but can you put all together? Can you answer those large questions, right? The big questions in science. And that's what people are looking for. I think that's the common factor in industry, the government, academia. How are you going to adapt? Because the world keep on changing. And then you have to be able to sell yourself and tell a nice, concise, a nice story when you apply for those positions.
How do you manage projects? How do you build these, like you were saying, you can do bioinformatics or PCR, but how are you using those to solve the problem, and what was the problem and what was the outcome? That's stories you'll get in the thing. You might say, oh, I can't put all this in my CV. Well, actually you kind of can. You can write your CV in ways where basically instead of saying you use PCR and skill sets, you have lines where that's added in for what you did. And your bigger picture, like, oh, we solved this problem through blah, da, 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 da. And that's going to lead to the questions instead of just having a section of, these are my skills.
Right.
Right? Use that, storytelling.
Mm-hmm.
Right. Work on your soft skills, okay? Technical skills, you're going to get it no matter what. Otherwise, you can't get out of your program. But the soft skills, that's something that people don't really ask for when you're doing your PhD or in grad school. But that's something that's very important. And he came from the industry. He hadn't said anything about technical skills. Most of the thing he says about soft skills, right? How to manage, how to talk to people, how to sell yourself. So again, we need to focus on those things more than is expected.
And that's something that's lacking a lot in STEM, is the soft skills. And we don't really have too many programs that teach you, unless you go looking for them.
Right. You put some people don't know how to put a presentation together. You copy and paste an entire paper and put it there. Nobody have time to read anything. Just need to be able to sell the story, like you said. Soft skills, how can you get there? So work on those things, okay? And there are many resources out there. And also people are very eager to help you. If you ask the question to the right person, they're gonna help you. They're very eager to help you. So reach out. Don't be shy.
Yeah, your graduate degree is going to put you in a position where you're not generally going to walk in as a technician. If you're going out and you become a scientist with then you probably missed the boat on what you're supposed to be doing with your PhD, right? You should so like you need to be able to work with people, right? Or you're not going to make it.
Right.
And PhD becomes so mechanic. If you go to what does it mean to have a PhD? When you get your diploma, it doesn't say PhD in virology. No, it just say PhD because it's Doctor of Philosophy. You should be able to use your skills, and any situation they throw on you, you should be able to find a solution. Now people are so concentrated on learning technical skills, not become a technician. No, you need to be able to think ahead of the game, have a critical thinking. That's what the PhD is also all about. I think people forgot about the meaning of PhD these days.
Mm-hmm. Yeah, there's big industry out there where, big giant computer companies will hire people who have PhDs that can talk. And they could have an organic chemistry degree and then go work on computers because they know that they've already developed the skill set to be problem solvers. Doesn't matter what the problem is, it's that you learned how to be a problem solver. After I got my PhD, I knew I could take a car apart and put it back together. Not that I ever will, but I have 100% confidence in myself that I can do it because of my PhD. It taught me how to learn, and it taught me how to ask those questions and solve the problem.
And gives you confidence to to do those things. Yeah, the definition of PhD, problem solving.
Yep.
Yeah,
that's what it is.
My advisor, he tells me very similar things where a PhD is to build up your critical thinking skills and your problem solving skills. And we have preliminary exam, your qualifying exam. It's called different things, I guess, at depending on the university that you get your degree from. But during our preliminary exam, that's like into the genetics program, it's 2 years in, so you're not going to have a ton of data that you're proposing. You have some data, backing up your project, but for the most part, they're testing your ability to think on your feet, and they're going to hit you with some hypothetical question. And I definitely had a lot of long meetings with my advisor where he'd ask me a question, and I want to be quick to say I don't know, but he's like, I'm not taking that as an answer right now. We're going to give 3 minutes, 5 minutes, however long it takes for you to think about it. I want you to think about how you go about solving the problem, even if you don't know right now. If there was some tool that would do this, how would you use that tool? So the problem solving is definitely, I also think how you can absorb and interpret information is another one too. Like you said, they have some companies might have somebody with a PhD in organic chemistry talking about computer science or coding or something like that. You have confidence that that person that has a degree in organic chemistry understands how to teach themselves certain concepts, even though they're not maybe the most educated classically in it. So definitely. Okay. So yeah, opposite from obstacles, what about maybe some highlights in your career, whether it be academic or your government career or your industry career that maybe stick out to you as maybe some of your proudest moments? And I guess the second part to that question is, are there any goals that maybe you set for yourself in the long term of your career that you'd like to accomplish or pursue?
Highlight my career. I always focus on the person. I think my legacy is, the people I mentored. My lab has been officially open for less than 4 years. I had 2 postdocs passing through, 5 students. They all got jobs. They're better than I am. That makes me very happy because that's my legacy. I want to train the next generation. It makes me feel old, very old. But it's just this internal satisfaction, to see somebody who came to you and you pretty much gave I would say, some mentorship, and they are doing better than you are. And that's, to me, that's the ultimate legacy I want to leave behind. So that's my highlight points.
Mm-hmm. Yeah, that's a huge highlight in my career as well. But I'm going to pick a different one, so we're not the same. But I'd say one of the highlights was I had worked with one company and ended up moving to another. It was a startup. I was employee number 7, and it took me a little while to build up a team, and I built up a wonderful team. Trained them up and picked the right people and got all the right equipment and everything. And I can just remember there was a day I was sitting in my office and I was started having anxiety, and I didn't know why. And I'm like, why am I having anxiety? And I realized it was just bored. I had gotten a group together that was so efficient that I literally almost put myself out of work because they were working so well. Like, it had become so fluid, and it was so, they almost didn't need me. They'd come autonomous. And that was a highlight. I stopped and was like, I could leave and the work would still get done because, I had brought the people together that needed to be together with the tools that they needed to be successful, and they were. And it was wonderful.
Yeah, I have a short story. So I was hired. I didn't do a postdoc. So I started my job, and then I had a postdoc, right, in person. And I did a lot of bioinformatics, studying viruses, population, whatever. So the project, she has to do a lot of bioinformatics, and she got to me like almost crying, shaking. Oh, I can't do this. I have zero knowledge. The next day she came to me, I'm going to quit because I just can't do it. So we sat down, and I taught her a couple of things and gave some resources. 3 weeks later, she was teaching me how to do things. And that to me was like, wow. And today she works for a company. She works in bioinformatics. So to me, like, wow, what a change, right? And that really made my day, and that's a nice highlight to my occupation.
It's great to hear that you guys' stories involve your team members,
Yeah, that is the biggest benefit. It's the same thing with like teaching. Like, you've probably had students that you've seen struggle with things, and I had a kid that I taught when he was in 7th grade. I taught him again when he was in 9th grade, and then I left the school, and I was the first person he called when he graduated high school, probably because I threatened to kill him if he didn't, because nobody else would push this kid, and I knew he was smart enough to do it. He didn't have faith, and he was waning, and he was going the wrong direction. And I said, look, if you don't shape up, we're going to have a problem. And he ended up graduating, and it was like, calls me, like one of the first people, hey, guess what? I just graduated, got my diploma in my hand. And like, yeah, I mean, it's just a wonderful feeling.
All right, so we have one more question for both of you guys. For Burg, what is your favorite discovery or project that you've worked on at your company so far? That you can talk about. That
I can talk about. So, yes. Yeah, so that's going to be a tough part. I'm sure that I'm allowed to talk about some of it to some degree, but I will keep it very vague.
Sure.
So, I was director of process development before I was in MSAT. And, prior to that, I had worked in process development at a different company. And, people were afraid of like using certain techniques of purification, specifically ultracentrifugation, because it's hard to scale up. If you're running 1,000-liter bioreactor, how are you going to spin all of that, right? And so people said, oh, you can't do it. And I said, yes, you can. And I currently have a patent that I don't know how far I can go in, but should solve the problem. And I just got recently, granted the money to build the second model. So I have the prototype. Second model is being built now, which should be more what we call GMP friendly. So I'll have all the software for recording all the data we need and everything like that. And then, hopefully in the next 6 to 8 months, I'll have that in hand and be able to start collaborating with, CDMOs and things like that to try to get that off the ground so that there is a way to actually make what somebody said wasn't scalable, 100% scalable.
That's really cool.
Yeah. So that was the beauty of being it's where your PhD comes in, right? Why I loved process development. I would try to break the system.
Right.
If somebody says you can't do it, they're lying. Science, we could do anything. We just got to figure it out still. Right. So, changing things, to make it better for everybody.
All you need is a good idea and some money.
Yep. And industry has it.
Right.
Industry's got the money.
So, Washington, I have kind of a 2-part question. I'm going to try to consolidate it because it could be really long if I just split it up. But I was looking at your profile in the Connecticut Agricultural Lab, and you described some outreach activities. You talked about reaching growers, lawmakers, extension agents, and consumers. And I'm curious what it's like educating that wide variety of the public. It seems like some people have some higher scientific literacy, and then some people, maybe they're being introduced to some of these concepts and your research for the first time. So I'm curious how that goes when you have those conversations, and if you have any advice to people that would be planning to incorporate that in their research programs or their projects.
Well, that's a very, very nice question. And I don't know if I have the right answer, because that depends where you are, right? Working in Texas and versus working in Connecticut, there are two very different things in terms of scale. So when I went to Connecticut and I was responsible for helping the grape growers, I was hired to work on grapes, grapevine viruses. And what I saw is that people knew more than me. They're extremely knowledgeable. So problems they have, they already found, if there is a solution out there, they already found it. So my discussion with them, and I do have meetings every year, it's called the Twilight meetings, where I bring some research data, sometimes from my lab, sometimes from other labs. It's more like a discussion, like a colleague discussion. They actually give suggestions. What if you do this? Is that possible to do it? Because they don't really care about what's already in the literature, because they already know. They keep up with the literature more than I did. And that was very surprising to me. So you need to know your audience, know where you are. I have friends working, in Texas and also Arkansas, and it's a very different reality because the farms are big, they have different problems. And then if you go to a place like Connecticut, things are very small, tiny, and the growth tends to be more insightful. I don't know. So my piece of advice is be humble. Even though we have a PhD, make sure that you listen to what the growers have to say. Most of the times they already have the solution. It's just like they don't know how to apply it, and they need somebody to connect to find the plug for those things. Try to understand where they are coming from, which problems they have, and how to find the best solution. And that's not one size fits all. So again, you need to know where you are, who you're talking to. In terms of the lawmakers, I think we need to have more scientists making the laws, because I am a member of the Grape and Wine Council in Connecticut. So we have meetings every 3 months with the commissioner, with the governor, some deputies. And what I get from those meetings is that they don't really have a full knowledge of sciences. And they are making the law. They're making decisions for us. So I think we need to do things like we're doing right now, try to educate the public, especially now the anti-science movement is so high. In terms of the law, we need to have more scientists involved in the law and become like lawmakers. I think that's the solution, because then we have good people to do that. It's just a matter of reach out and try to get into that field.
Great answer. And you kind of hit on I had another question after, but you already kind of answered. I was going to ask you, how does the scientist's role fit into the legislative process when you have those conversations with lawmakers? And I guess what can any PhD or any scientist do to try to, impact public policy in any way?
That's a tough one, because you really need to be a politician. You need to be able to navigate through all the policies. When I go there, as a scientist, you're trying to find problems to solve. They come from a mentality where they want to win the next election. So any change they make, it needs to be, in a way that's going to benefit them. Not necessarily through science, the best for science or for a certain group, but for the overall population, because that's how they win an election. So we need to come there with an open mind. And I'm still new in this position. I have been there for the last 2 years, and I'm learning a lot. And especially, be able to just sit back and listen to what they have to say, and see how we can, in a way, convince them to make those changes. It's very hard, because they really push hard for the agenda they have. And again, most of the times, not to benefit the growers or the agriculture as a whole, but to benefit the society. It's very indirect ways that they look at things. It's how much money you're going to make, how many jobs you can open. They don't look like far from the horizon. It's just like a quick fix, per se. So it's a learning curve for me, and I think you need more people to be involved in that type of thing.
Today's episode was hosted by myself, Joe Romanowski, and Anthony Matarazzo, and produced by Brittany Ming Whitfield and Emery Alexander. This podcast is brought to you by the Texas A&M University Interdisciplinary Graduate Program in Genetics and Genomics. If you have any questions about our program here at A&M, please feel free to email us at bluejeansandboots@gmail.com. You can also find us on Facebook, Instagram, Twitter, and TikTok at Genetics Podcast. Thank you for listening. We hope you'll tune in next time.